And now I'll move to the part where you joined NASA in 2007. And so that I don't make any mistakes, I sort of jotted down what your profile says on the JPL website so that I can talk about your interests precisely.
No, don't worry.
And so the website says that your research interests can be broadly defined as understanding the physics and chemistry of interstellar and solar system ICES through laboratory simulations, observations, and instrumentation. So tell us what made you passionate about ICES of the universe. I actually got to know about this when I started exploring your profile. So it has been quite a learning experience for me as well. And what do you study when you study about ICES of the universe? Your Skype ID has, Ice Murthy.
Yeah,
So that tells me how passionate you are about the field. So educate us.
Yeah. By the way, there is a openly available PowerPoint presentation on NASA website.
Yes.
Exactly, ICE of the universe.
I'll add the link for that in the description of this video so that people can access that as well.
Yeah. So the thing is, there was another period, by the way, we didn't discuss. After my PhD, because I met my present wife at the time we were dating, we were working in the same lab. We decided that we go to Germany. So we went to Germany, and I was working for 1 decade in Germany, teaching there at the University of Cologne. So and that's where I also used to teach in German as well. I was at that time I was doing mostly low temperature physics using synchrotron radiation and photophysics of all kinds of molecules and atoms in condensed phase. Then, the back of my mind, I have always been fascinated by space and astrophysics and space. Then once I met a colleague at one of the Gordon conferences, and that is and that's where we started discussing, and he was working at NASA Ames at the time, Ames Research Laboratory, and he was working on ice, ice-related research. I was really fascinated by that, and slowly started looking into it. And then after 5 years later, we started collaborating. Then I went to NASA Ames, and that changed my life again, because that was the stepping into real astrophysics and planetary sciences. See, ice is something that is fascinating to me. Being born and brought up in the hottest, place after that. Andhra Pradesh, maybe, it's a pun to think that, oh, you like ice because you don't have any ice or any snow or anything like that. I haven't seen real snow, natural, snow until I was about 32 years old, when we went skiing. No, in Montana, not 32, probably about 27, 28. We went to Montana in years when I was in Austin, Texas. That was the first time I saw snow. But until then, I never saw snow and ice, real one, okay? So the reason why it started becoming a fascination and later on obsession is that ice, most of, let's say, even in our solar system, if you look into it, the void between planets and their moons is filled with, let's say, some kind of debris or dust. So, and this is just an example I'm giving you to compare our solar system. And if you go between stars, which are separated by several tens of light years. Okay,
Yeah.
it's a really huge distance, and that void is extremely cold. But even in those voids, there is material, which is probably 1 molecule per meter cube or something like that. And so that material, because it's so cold, except for hydrogen, most of the other, probably helium, yeah, hydrogen and helium, most of the other elemental material or molecules, uh, they as soon as they collide with other molecules or grains, they freeze. So the frozen gases and other molecules dominate those voids. That is what is called as ice. So most of the material exists in ice form, as I said, except for hydrogen and helium.
But when you say ice, it means that it's not the regular water, frozen water. There are other elements that could also take those structures and are called ices.
So yeah, so the normal definition of ice is water, frozen water. But any gaseous molecule that we have, or atom, for example, argon. If I freeze argon on a cold target, it becomes ice. And in fact, I did make a very big ice of argon when I was a postdoc. So that frozen material for argon, carbon dioxide, carbon dioxide is dry ice, okay? And so all these molecules under certain conditions form frozen material. And that's what we call as ice generally for all the molecules. Of course, water ice is also a dominant thing. I will come back to that. So now, if we go into the planetary system, even moon has ice. Okay, our moon is so close to sun, like Earth. Of course, Earth has ice because we have atmosphere, and so because of the atmosphere, the pressure is higher. And in the phase diagram, you see this is where water, ice, and vapor are in equilibrium in certain parts. So this is unique. Earth is very unique in this regard. But moon doesn't have atmosphere, not much at all, but it still has ice because there are certain craters on moon which never get exposed to sunlight. So very important thing in our solar system is that the sun is constantly sending energy, in terms of thermal energy, infrared energy and UV energy, whatever it is, and solar wind. And this energy heats the molecules and minerals. On moon, there are craters which never get sunlight. And if you go into caves on Earth, they also get really cold because there is no, heating up through radiative transfer. Radiation is not, thermally heating. But at the same time, these bodies are radiating heat away into the space. The background radiation is about, I think, 4 Kelvin or something like that. So they become radiators, emitting energy away, but they don't absorb energy. So moon has water ice, Earth has it, Mars has plenty of it, water ice. And if we go beyond even the asteroids, recently we found that asteroids have ice. The Dawn mission has shown that, and beyond that, almost all the outer solar system, bodies have ice, water ice. Now we are talking about water ice. Giant planets, moons have ice. Saturn's rings are made of ice, and so everywhere there is ice. So that's the fascinating thing. And one more fascination for me is I'm again, if you remember what I said, my fascination to do science is to understand what is why it is like that around us and within us. So one of the fundamental questions that every one of us asks is that life, how did it happen? Is there life elsewhere? Okay. Instead of listening to those, science fiction stories about Martian aliens and all those things, we are more serious.
There are just so many coming up. So
it's all what I call it as BS.
I wanted to ask this question to someone who's in, NASA or somewhere, that when these documentaries or these TV shows come up, do they ask for advice or clearance from you guys, or they can just show anything that they want?
Yeah, the thing is, free press can do whatever they want, but you have to be very careful in wanting to believe. Never believe what you hear on press or in the papers. In fact, I get questions from some of these Facebook friends from corners of India, saying that this is what they said, and they said typically what they say is some BS there, and then they say NASA has discovered it, and which is absolutely wrong, because I tell them, you don't have to come and ask me. Go and search internet and look into whether NASA has published or given a press release or news release on this topic at all. If there is no press release, there is no news release, it is all bogus news. Okay. And so that's, yeah. But the thing is, the serious aspects of ice is that water is one of the very important ingredients of life. Okay. At least as we know of, there's only one kind of life we know that connects from archaea, the initial bacteria, to the evolved human being. We all are connected one way or other we think that through evolutionary process, which seems to be more robustly established. Water is needed, and organic materials are needed, minerals are needed, energy is needed. And so that's why wherever there is water, there is a chance for life to thrive. That's why water and ice becomes an important thing, because if there is ice, there could be water as well. That means liquid water rather than solid water, which is ice. That's also the reason for my fascination. And finally, as I told you that a NASA researcher was, working with ice, what in his group they found was that if you take water ice and simple gas molecules like carbon monoxide, carbon dioxide, ammonia, or methanol, these kind of simple molecules, which are actually found in the in the dust and ice, I said, between the stars, the voids. Yeah, it's called interstellar material. And in fact, that interstellar material is the beginning of birth of a new star and solar systems. What happens is this material, which is also icy and non-icy material, slowly comes together through collisions and things like that. When it becomes bigger and bigger and bigger, at one point there is what is called as gravitational collapse. The cloud becomes denser inside, and then it collapses. As it becomes denser and denser, it starts igniting. That's the time when a new star is born. But around that ignition, where you start even, having nuclear reactions like, hydrogen becoming helium and things like that, you form a disk of material, and that disk of material slowly becomes, clumps together to form planets-like thing, or asteroids or cometary material, things like that. So solar systems are born through that material. So what we think is, in his lab and the other labs, we found that when this interstellar simple ice with water is exposed to energy, radiation, and light energy that is available in these areas coming from the other stars, the chemistry that happens in this ice is fascinating. We found that that simple molecules lead to formation of complex chemical entities, and some of those complex molecules include, as I said before, the fundamental building blocks of life, such as I'm not sure whether I said it or not, but like amino acids, lipid molecules, like long chain fatty acid molecules.
And those are actually forming in those star-like structures when all these things come together?
Not in the stars, but in the interstellar ice grains.
Okay.
So
you have amino acids forming there up in the space?
Yeah.
Okay.
Yeah.
That's fascinating.
Yeah. At least we have not seen in the space, in the interstellar space, evidence for happening in these grains, but we have seen that in the laboratory, because it's difficult to interrogate these ice grains for small, let's say, minor components that are found there. These are not the major components. So major components are very well established, and we take the major components and to simulate what could happen there, and then we see that minor components are made, which are even in our lab we have shown that if you start with these molecules even at very cold temperatures, 10 Kelvin or 20 Kelvin, that is the temperature of these materials there. You form formamide, estamide, and all kinds of these kind of amides that are intermediates for higher amino acid-like molecules. But the interesting thing is, in most of these ice-like material in those interstellar space, there is already the conditions that are necessary to form complex chemical entities. And we think that these are the things that have formed in those days before even they got collapsed into a star. And then when it collapsed into a star, in the middle, everything gets destroyed because it's so hot. But on the disk, which is far away, they are still preserved. And we think that some of those far away preserved icy bodies are present day comets. So there is a theory, there is a theory that in the early stages of our solar system formation, Jupiter and Saturn were not in their place as they are now, but they have had some fight, gravitational fight. When they had the gravitational adjustments and fights, there were so many these comets and asteroids, they were scattered everywhere. And so what all they came into the inner solar system, bombarded on Earth and Moon and even Mars, and that is one of the reasons why Moon has so many craters on its surface. And we think that the comet-like material that bombarded on Earth brought not only water, but also the complex organic molecules that we are talking about, which were happening somewhere far away, billions of years ago. And that we think that they were brought onto Earth. And that actually, immediately after that event, we have the indications of first life forms on Earth. So that particular event where these molecules were brought onto Earth might have triggered subsequently the transition between lifeless to life. So that's, you see, that's slowly.
Yes, I see how your work of, studying the ICs of universe is again in the direction of answering the original question that you want to sort of answer since long time. And I wish you all the luck for that. And in the middle, you said that you try to simulate all these conditions to sort of replicate them. So are these thermodynamical calculations that you do using different packages and software? Or you actually do experiments? And if you do experiments, how do you sort of replicate those intense conditions that you have millions of light years away on Earth in your lab?
Yeah, we don't do modeling or theoretical work, but I left theory once I left University of Hyderabad, probably IISc. I was in quantum mechanics or quantum chemistry at University of Hyderabad, and some theoretical calculations at IISc. I'm more now hands-on. We have a reasonably modest lab where we simulate everything. I think what we cannot simulate is the conditions that are on Sun, but we can simulate almost anything else. The coldest temperatures that we can get to cool large amount of material is about 3 to 5 Kelvin. Okay, and as you cool down, also we also use the vacuum conditions that are prevalent out there. So temperature and vacuum conditions is not a big deal. We can achieve it for a reasonably big sample. You can go to sub Kelvin if you are talking about cooling atoms, Bose-Einstein condensates and things like that, but we don't go to that temperatures. The radiation conditions, what we do is most of the photon radiation out there is caused by hydrogen emission, because hydrogen is the most predominant element in the universe, and wherever there are stars, the hydrogen not only fusion occurs, but also electronically it gets excited, and so it emits radiation. So the background photon radiation has a hydrogen emission as the strongest emission. So we use that hydrogen by simulating discharge. We also use photons. We use lasers, tunable lasers for that, and we also use electrons, because electrons are in solar wind. There are electrons, and for example, in the recent times, as we start working on Europa, which is Jupiter's moon, where we are going with a mission now, that demands entirely different set of experimental parameters. For example, there electrons are accelerated to mega electron volts because of Jupiter's magnetic field. So to get that one, we go to NIST, and where we have their mega electron volt tunable electron source. We also use solar wind protons and other other ions. So we generate them. Essentially, almost all those things. And recently, we started going not only to cold ice, but very hot exoplanets. So extrasolar planets that we discovered in the past couple of decades, they have much higher temperatures, like 1,500, 2,000 Kelvin, or even higher. So we started simulating in the lab atmospheric conditions that are up to about 1,700, 1,800 Kelvin. So you can do that. It took 5 hours, not 5 hours, 5 years for us to develop that facility and publish some first of its kind work. So everything is done in the lab.
Okay, that's great. Thank you so much for educating us on the ISIS of universe and all the exciting work that you're doing and the learnings that you have had along the way. I would like to switch gears a little now and talk more about the kind of activities that you've done throughout your life and how they probably have contributed into the individual personality that you have become overall. So you've been a caring son and a caring brother, as you've told us throughout in bits in the interview. You've been a loving husband, and you're a doting father. You have two lovely daughters. You haven't been, is it? You have three daughters. I know
Yes.
only two of them. Okay, so you have three daughters. My bad.
Yes.
And then you love hiking, and you've talked about bicycling and a lot of other physical activities. How do you think all these components have contributed into the successful professional that you've become in your life? And are there experiences that you have learned from your research life or skills that you have learned from your research life that have also helped you as an individual and in your personal journey, as we say?
Yeah, I think that's a very, very important point and question as well. What we learn from research is as you become engrossed in science at one point, the differences melt away. Whatever you learn in your science professional thing also applies to your personal life. One profound thing that I learned by changing my research career into planetary sciences and astrophysics is we have been searching for life everywhere in our solar system, and we will be searching for life everywhere in our solar system. And we are looking elsewhere for signs of life in other solar systems, in our galaxy or other galaxies. But until today, we have zero evidence, zero proof for life elsewhere in the universe. That doesn't mean that there's no life there, and that doesn't also mean that there is life there. We do not know. But what we definitely know is, damn it, there is life on Earth. Isn't it?
Yeah.
There is life on Earth. So here is life. This is the unique place so far. Life is precious. It doesn't happen everywhere, but it happens everywhere on Earth. And this is one of the most unique things that happen to us, and we need to preserve it. We need the ecosystem, the biosystem, the diversity. We need to preserve it rather than abuse it. Okay, that is what I learned from this, because every life we have here cannot happen wherever you look. If we shout into the space, you would never get an answer. So that's what I learned. We need to take care of this Earth. We need to take care of all the lives. And that takes me also to my philosophical aspect of becoming a vegan, but that is, on the side. We need to respect life. we need to respect each other. And so that kind of thing is very important because we don't know how long life on Earth could survive. If there is a huge asteroid impact, we may be destroyed. And I think it may be very difficult to stop an asteroid of that size coming onto Earth. But though NASA and other agencies are seriously working on, mitigating this kind of things. But if it happened like 60 million years ago, where all the dinosaurs and other forms of life were eradicated, it may be end of humans. But we need to make sure that we except for that kind of uncontrollable natural events, we need to make sure that we do not destroy our own selves. We do not destroy the biodiversity. We have to, as you said before, we have to celebrate life. And that's what I learned from that. From the science point into my personal life. The activities I have, they're, I think I learned a little bit from my wife at the time, is that I used to mostly focus on, science, and get papers and all those things. She had a different view. She said, okay, you do science, but there is something else in life. We go hiking, you need to put time for that. And that actually helped me a lot and I realized that I would more efficiently use my time if I say that every Sunday I don't do science, but I go hiking or I go biking. And nature being such a intricate part of my life from my childhood, it is where I feel really peaceful and in resonance with myself. We go hiking. As you have seen, probably, I was so very happy about doing Annapurna base camp hike in Nepal and Himalayas. So yeah, Mom, and by the way, but from the beginning on, from my childhood on, I used to play, ball badminton and, later on tennis. And, these are, you need to respect your body. In order to respect your body, you need to give what is healthy for the body and, and mind, of course. And you cannot abuse the body. So that's the reason why doing exercise is important. Whether you do yoga, whether you do, whatever you want to do, that compensates, as I said, the other part of your life. Cooking is a hobby that I have, and what else? Yeah. So it is.
Another passion, yeah. Go ahead. No, you finished, and I'll say.
Yeah.
I was saying another thing that you're passionate about is education for all, especially the underprivileged kids. And I think it sort of also comes from the experiences that you have had as a child. So why do you care about education for all so much? And what kind of changes do you envision if it's accomplished?
There are two things that I have been thinking from my childhood, again, in addition to all the other things. One is vegetarianism, the food we eat, because just a few minutes ago I said we need to celebrate life, we need to respect life. And so I wanted to be conscious of what I eat, and killing an animal to live for me was very difficult, because as a child I grew up in my grandfather's house, where we had a lot of cows and calving, and I used to play with the cows and all those things. It was very emotional attachment. And later on, I could never ever touch meat. Even I think I ate eggs very early in my life in India at one point, but then I gave up also eating eggs. The thing is, we need to live consciously. And the question that I had been asking is vegetarian life or is vegan life is it the only thing for everyone, or is it only for me? I didn't have answer for that. Even today, I don't have answer for that. But what I definitely think there is an answer is that every individual should be conscious of what they are eating, where their food is coming from, how their food source was treated. Okay, that is important, because if you know that, and if you know that that life was respected, then you know that you fulfilled your conscious living. Okay. I do not tell people don't eat meat. It's up to them. My wife is a meat eater, but we don't cook or store meat because of my emotional attachment to animals. So that's one question that never got resolved. Other question that I have been looking into is, why do we have conflicts in this world? Why are people blaming each other, killing each other, abusing each other, either in terms of at individual level or as factions or as nations or as some kind of religious or fanatic entities? And I thought, what is the solution for that? What is the solution that humans can become better than killing each other? That had been happening throughout the history of humanity. And I realized that, at least for myself, I may be wrong, that, education in science, mathematics, STEM education, especially science, mathematics, and arts, for example, trains your mind to think logically. And that is the most important point of education. It's not about getting certificates and getting a job and buying a refrigerator and a car and a fan or whatever it is. It is the ability to use your mind over your emotion. And it gives you an opportunity because, the educational process has that inbuilt in it. So my thinking is, if every child, newborn child, at one point starts getting education, we may give them a choice to act rationally, at least part of their life, than instinctively and emotionally by taking sides and by being violent, either knowingly or unknowingly. I thought we can reduce many problems on Earth if every individual gets this education, particularly in science, and of course the social education, social sciences, geography, and all those things make you more aware of our surroundings, much bigger, as we talked earlier. And the other aspect is, you cannot change a grown-up. It is, you can just give up on them. Once a person is 18 or 20, it's forget. They're like that and they will be like that. You can probably polish a little bit, but you cannot inherently change that person. But when you go for 6-year-olds, 8-year-olds, 10-year-olds, 15-year-olds, up to probably 18, and just in that age, you can actually give input for them to change in their thinking process. Okay, that is the reason why I think whatever the time I have, other than what I do and what I have to do, I would really like to put it in helping next generation children get education in a small level, whatever it is, whatever I can do. And finally, giving education for girls is extremely important. In fact, in the we should not say poor. I don't want to use those kind of adjectives that make people sub alternate or something like that. I say underserved. There are communities, irrespective of their caste, religion, blah blah blah. I don't care about all those things. Underserved environments where parents do not have the privilege to A, know the value of education, B, provide the education. If girls in those environments are given education, they would be able to better control their life. Like my mom could not control her life because she stopped education at the age of 5th grade, and then the only thing that she knew is that her dad went around and looked for a boy and got him, and then got them married, and then done. Life was over. 10 years later.
But then she had you.
Yeah, and 10 years later, my dad died. So everything was, so whereas if we give the education and the ability to, let's say, earn their living on their own, girls would have much more control on their own fate. They do not have to bear children at the age of 18 or 19 or 15 or 16. They can self-determine, and that actually changes the society also. So these are all many things that I think came together to the idea that we all need to put some effort to empower, educate and empower underprivileged in every part of the world. And why I'm doing this in India is that not only to pay back, but also it is more convenient for me to do it there than elsewhere because of my interactions with IISc and other things. I think this one thing where I get the analogy to the proverb, whether it was a fact or not. When Lord Rama was trying to build a bridge between India, to Lanka, Sri Lanka, every squirrel, helped by putting some sand there. So we are all squirrels, and we need more of the squirrels to do small things so that we can change, we can build bridges and we can change the societies. I cannot do it alone. I only hope, I dream and I try to do small things. But there are so many people who are doing it, but we need millions more privileged people to donate a part of their time that they waste watching junk movies to go to a school of underprivileged surroundings, try to get more students and give them opportunity. Tell them these are opportunities. There are so many people who will be willing to help if there is a financial need that can slightly improve the situation. There's no point in pouring money into something that will not work. As long as there are no people, there are no boots on the ground, there is no passion, at the core level of millions, we will not achieve this change. But that's my hope, that millions participate in doing small things that change the world.
I have to say you've been an amazing squirrel, and I hope that your story inspires a lot of squirrels to follow their scientific dreams, and then millions of squirrels to come together and contribute into celebrating life and making it much, much better for all people around us. Or not just people, but all sorts of lives that we have around us.
Exactly. Yeah.
Yeah.
And we are fortunate to be given this world, and let us not screw it up. Let us give much better world to the future generations of all the things that are under this biodome and its environment. Not only its nature, its environment. Everything is important to keep it in a sustainable way.
Yeah. Thank you so much, Dr. Murthy, for just so calmly, candidly, and honestly talking about your journey, taking out time from your busy days and sitting down and having a chat with me. Thank you so much. I hope your story and all the learnings that you're sharing inspire future scientists, and also the common people who watch us learn how they can contribute into making the entire earth a better place to live in.
And their life also better.
Yeah. If they make the earth better, I think everything's gonna be fine. So
Yeah.
we don't have these pandemics, we don't have global warming and other things. And
We may still have them, but we will be much better equipped to minimize the damage caused by them. Yeah.
Thanks a lot again. You have a great day ahead.
Thank you, Navjot, and feel free if there are any questions, and if people want to more information or talk to me. But be honest with yourself. Be proud. Be proud. Be honest, and don't go for freebies. Go for hard work. Come on. Hey, I want to see that that kind of self-respect, not the kind of things that people blame each other, but put your own self-respect and say, yes, I can do it. Yes, we all can do it.
This is a great note, great motivating note to sort of end the conversation. Thanks again for all the wise words and for sharing all your life experiences.
Thank you. Take care.
Take care, you too.
Bye.
Bye.